Can you hear me? I hope you can do it. My name is Dinorah Tovar, and I am mobile engineer at Confio, which is a startup in Mexico City. We do CVMs, lending, and credit cards for pretty much small enterprises. Yes, I recently got my Google Developer Expert badge. So I'm really excited because this is the first talk we are doing with that title. So I have to put it on Medium of this talk. So uh, before we start, I want to say thank you to Android Worldwide and all the sponsors and all the GDA groups and everything that is going on in there, because they are amazing. They are the real MVPs that are doing this possible. So a huge applause. I hope you are doing it on your home, because I'm doing it on my own. So let's get started, right? So pretty much data is really important. At the end of the day, data is what our users are seeing every day, right? They are doing pretty much any action that we are throwing to our user is data driven. So you might have something like this. You might have your presentation layer, your domain layer, and a data layer. It might not be like this, but it is. That's pretty much your presentation layer. You know this already is a UI. Everything that's going on in there, maybe a scroll, a click, everything that that is in between of that. The part of the domain layer are model entities, because we don't want to populate the object that we are bringing from our server to our view, like directly. Or maybe we have something else. If you don't have this, it's okay. And we might have some layer that has some data. Maybe it's connecting to some network. Maybe it's doing some Apollo things. Maybe it's getting a database. And this is huge. This is huge. This is really, really important. Because at the end of the day, and I'm not saying that you might have this architecture or might not have this architecture. Remember, architecture is not about a recipe. It's not like creating a pie or maybe doing some hot dogs. It's not like that. Architecture is about the product you are building. So if you have the data layer part, the network, and the local part, you might find that I'm writing two serials. The first one is Practical Network for Android Developers, that is already on the blog, and you can check it out. In this talk is a complementary part for that, because in this serial, pretty much everything that is going on is about network, is about interceptors, is about what happens when you are pushing data from an API. But this talk is not about that. This talk is about data and storage and the things that you have on your application, right? You might have some app-specific storage, maybe some shared storage that is shared between your app and multiple apps, your preferences, and your databases. At the end of the day, this is pretty much what every Android app most probably has. Maybe the purple one, not everybody's using it, but if you are, so maybe it will make sense to you. Everything that is going inside this app storage are files, are things that you want to write. There is some media files, maybe some documents, and the part of the shard store. There's the shard preference. This is really important. We are going to be talking a little more deeper about shard preference, especially because they are designed to save data that is primitive, right? A boolean, an int, maybe a list, but has been doing some weird things, right? Some people are trying to save maybe a full JSON in there, like trying to save an object, and they don't want to do a database, so they are trying pretty much try to do that. There is a solution. I know share preferences are now easily encrypted, so we are also going to talk about a little bit about that. We have databases that pretty much are SQLite flavored, like they have maybe some wrappers on it. They are putting sparkles on the original version of SQLite. And today we are going to have three main details that we want to discuss. The first one is performance, and it's pretty much detailed performance of how you can do queries and transactions and things like that. And we are going to be talking about threading. So performance can be really dangerous because your user might do some click and you go to some request, some server, you have your API, and the API might respond quickly, but you are trying to write to your database or maybe a file. And if you have a huge amount of data happening on the write to the database or maybe to a file, this is gonna get in slow. If you're putting this in maybe a coroutine or maybe an Rx Java or maybe something like that on several, I don't know, this part in here is gonna take a lot of time, and it's gonna look funky and kind of weird in your phone, and your user are gonna say this has so many lag, and you don't know why, because maybe we are doing something that is not properly addressed. So for the files, I'm not gonna get in so many. I'm not gonna go deeper. You can go to Jesse Wilson public object blog. He has this blog post that has been stuck in my head for a couple of days now. And he said that when we write a file and we are doing it poorly, when we are trying to put just only code and we are not thinking about the performance that we want to deliver, we ended up doing something like the code that is on that image. I don't know if you can see it. You can go to public object and see it. But actually it says that a file that is 100 megabytes is going to take almost 7 minutes to get copy. And it makes no sense. This can actually be a huge problem if we are doing it wrong, right? Your user might not be 7 minutes in your app. You can put it on a worker. Yes, you can put it on a worker. Maybe you want to put it on an intent service or something like that, and it will make sense. But actually, if you do this, you are doing it wrong. The performance sometimes has to do with the code you are writing. So after you check Jesse Wilson blog post, you will notice that he works at Square, so they are working in a new version of Okio to have some corrections of these with files. So give it a try. Go to the blog of Jesse. At the end of the day, when you are trying to address an API and try to save data to a file or a database, at the end of the day, you are doing cache, and cache can be a lifesaver. Because you might have database caching, which is important. If you go to my blog post, you will see that you can have CDN and DNS. But the really important part is the database caching, because it will provide some impactful factor for your app performance, right? If you are doing your databases and there is some funky code that you can improve, this is gonna get you are gonna get really slow times. The local cache is not gonna do the job that it has to do, because the API is gonna be faster than the performance in your database. And another, well, usually use SQLite, and it's pretty much because millions of companies are using it, right? And they scale well. Like you can use it in any project. It will scale well. It will make some cool facts, right? So at the end of the day, we are doing in ground. We are consuming memory, maybe CPU, maybe we are doing some extends use of the battery, and there is a lot of flavors or RMS that are doing a flavor version of SQLite that you can use, and it's a wrapper, and it's pretty much a little more pretty than the version that you are using. And there's SQLite, there is Realm that probably a lot of people are using because they want to encrypt their databases. And it's pretty much more simple to do it in Realm, because you can create just a key store and adding this key store and create a load key, and the load key will be pretty much simpler. There's SQLite Lite and there's Room. But there's a lot of things about SQLite Lite, and that's why Room pretty much born because there's a lot of runtime crashes, there's a lot of boilerplate, and pretty much there is not observables. Like you will not be able to control the cursor windows when you are in it. So let's talk about some old alternatives. So pretty much any alternative that you are looking for, if you are looking for a really elegant version of it, you can go with maybe some compile verification, or maybe a type safe API. SQLite Delight that does that. The compile verification goes for Room. Simpler migrations, I think I have never seen a simpler migration as the Realm migrations. They are pretty much the most simple thing that you can do. There is coroutine. You need to have some support of that part, because if you have support for that, you can handle the threading a little better and make sure that everything is going on the background thread, and that you have control of the transactions and all the inserts and all the updates. And this is pretty much because we need to address that when you are trying to build a product and this product has too many tables, and I'm not saying 5, I'm not saying 10, I'm saying like 100 or things like that. When you're building these kind of products that are pretty much of line third options, you have to be really aware of these 3 parts, right? You don't want to have things that can get broken because you don't review the code when you push the data to the Play Store, or maybe when you want to add a new table, you can do it faster without being a problem more than a solution, right? So, Realm, SQLite Delight. I love Realm. I don't have any problem with Realm. We are not talking about this, but I'm going to tell you why. Realm is amazing. It was purchased by Mongo a couple of months ago. I didn't even notice, but they are belong to Mongo now. They have executable transactions. They put so many callbacks, so you can be aware of the result of one transaction, right? They have listeners, on-chain listeners that are amazing. You can put it on your view and just populate the data. It works like a charm. Like Realm is amazing. It has Realm browser that now we have on Android Studio with the Data Inspector, and it has pretty much the best and easy encryption in the world. You can do it like in probably, and I'm lying, like 50 lines of code. It's really simple to do the encryptation of our Realm file. And for SQLite Delight, they have type safe. My favorite here is that they are Kotlin multi-platform first. So if you want to do it and you have a project that is doing Kotlin multi-platform, this is your way to go, and it's amazing. It's open source, so you can contribute to it. I believe it's on the Square side, so you can give it a try and go to the GitHub. It has support for threading, Android paging, Java, has tons of things. But today we're going to be talking about Room, because this is pretty much what is the standard, right? So Room has compilation time and verification of the SQLite queries. It's amazing. It makes it so simple at the end of the day when you are trying to migrate from SQLite to Room. It's going to be really, really simple. The migration, I have a full guide in my Medium, so you can give it a try. And obviously it has Coroutines and Flows. And today we're going to be talking about specifically that part of the Coroutines and Flows, because that's threading and that's concurrency. And you will find that it's not as simple to put just an insert and just do it without thinking of the threading. But if you want to try and see more about some other options, I recommend the SOC from Sam Edwards, Select from Kotlin. It's amazing. It was at DroidCon New York a couple of years ago, so give it a try. It's really, really nice. So you might hear these rules when you are trying to do queries, like only take what you need. Don't grab everything, because we are not a hovers. You have to use foreign keys, maybe some primary keys and some relationships. But I want you to focus on the use of transactions and the use of coroutines. So we are going to check this out. I know this sounds like the simpler way to do it. Let's do this query and let's not worry about it. But actually what we need to do is go to the specific ID and go to the specific variable that we want to pop from the database. And this might sound silly if you have small tables and small data, but I was engineering this huge company that were having guides for cities and for traveling and things like that. And we have pretty much 200 databases, tables on the database. So the joins, the inner joins, and all the relationships that were happening between the tables, it was so big that usually a query was taking maybe around 20 lines of code. So we need to make sure that we are not selecting everything on the database, because if we are doing it, we're doing a mess in there. So the other part is that foreign keys are not for performance. I know they are integrated tools, but they can boost performance if you put some indices, and especially when you are doing some deletions, because here in Room you can do a cascade of the delation, and it will be simple for you to track all the things you have to delete, especially because you might have some joins inside of it. So it will give you a chance to make it simple. This is pretty much. I don't want to say this new, but you now can have a relationship one-to-one, many-to-one, many-to-many, and so many relationships inside Room. So that's pretty much cool, because it can save you tons of times. Go use it. If you already have Room, please push it with relation. It will make the lives of the developers easier. So please do it. A transaction makes that all the database operations you are executing are running inside this block of code, right? It's really nice to use it for relationships, maybe to push a really big query when the results can take a lot of time, because you might get that the data can get corrupted if you don't do that. You not do it on a transaction, right? For example, if you have some relationship field inside your database, and these operations are going to be executed in different moments. You will go with the relation first, and then you will push for the object you are searching, and then it will be inserted in the block, and you will get the object you needed. So transactions are amazing, because you can choose if the transaction will be running in some coroutine scope, or it will be running in some specific dispatcher. For insert and delete and update and all of that, this already is happening inside a transaction. This already is running on that. But if you want to keep track of the transaction, to go and do an insert, and this insert gets the correct answer, and then doing the delete, you have to do it something like this. You have to englobe all that that functionality on a transaction, because if not, you will get blocks of code that might be not matching. And coroutines can be used with anything. And when I say it can be used with anything, I mean anything. It can be used to get from the first, in the first part of the code, we have an insertion of a user, right? And it goes to a user entity, and this code is synchronous. It will happen on the thread you are sending it. But the second part, you are doing a suspended version of it. This is really cool, because if we can put suspend functions inside our Room tables and try to do this insert, this update, this delete, all the queries that we need to do it, and put it on the right version the code, you can save tons of times. And I don't know if you know this, but Room generates code. So today we're going to review some of the code that is getting generated when you are using a suspend function and when you are trying to do an insert without doing on the synchronous side, right? So it can be used for anything. That's applied for queries too. You will get a suspend function. If this was Android Studio, you will get the little icon that goes with the suspend function and only can be called from a coroutine. So you get the drill. You will get some queries, maybe some inserts, deletions, and you can even put some transactions. If you can put some transactions, you can make sure that all the inserts, all the deletions are being successful. But especially, you can track all the deadlocks that you might have. And we are going to be talking a little more about deadlocks in a couple of seconds. Trading and concurrency is enormous. We think we don't have trading and concurrency when we are doing databases. And the reality is that we have we have trading and concurrency because we might go and do something like this. For example, you go your app, your user is inside your app, and he's maybe doing some clicks, some scrolls, and we might have to go to the internet, get a response, try to write it to the database, maybe to a shared preference, or maybe you are using DataStore or something like that, and you will get the thing you are gonna be pushing. Maybe it's gonna be the local cache first, right? Because you want to give it some details to the user without having to wait for the response of the internet. But you have to update the database too, and then deliver the result that is going to be pushed to the view, right? So we don't want funky performance. We don't want some details on how we are going to build it. Maybe we don't want to have the user notice that we are doing some things. For the user should be seamless. And I am a product. I'm on the product side of the delivery of things. So if you are not be careful here, your user are gonna put some 1-star review on your Play Store or maybe in your Apple Store, and they are gonna say there's lag. This doesn't work. I'm hating with all my life. And there you go. You have lost a customer if you do this. So for the part of the databases, you might use suspend to try to make it simple, and make it a little better that the things you are going to be using if you are trying to do this process on a synchronous side, especially if you have so many data and you want to push all the data from, I don't know, maybe some stores. Maybe you are a retailer and have like 100 stores and the user wants to load the map. And if you are not doing it right, the map is not going to move till the user gets all the results from the query, right? So for the part of the synchronous call, we are going to see the room generate the code that is generated by room. So what is going on in here? Yes, I know it's Java, but it's going to be Java. So the part of room, what you are gonna end up is with this function that is a insert product sync. That is is this function, the first one you are seeing. This one is gonna get a final product entity with the product that you want to put on your database. And inside of this, what is going to happen is that the database is gonna start a transaction, right? And inside this transaction is going, and everything of things is happening in the main thread, right? This insertion is going to happen. It's going to push the transaction to be successful, and it will end the transaction. It doesn't even care if the database is open or is in another transaction. It doesn't care if we are executing all the code or even if the database is closed, right? For the part of the asynchronous, you might have something different, and it's really different because what you are going to have is a function that is going to be also in Java. It's going to be an insert product suspension. You will be able to populate a product, that the element that you want to populate on a database. This part that is a continuation. This continuation is pretty much a variable that under the hood suspend the functions and converted by the compiler. This part of continuation solve the issue, because inside of this we are gonna do some coroutine room execution. This part in here is gonna give us. You can go to the ROM documentation and try to review what is going on in here. But at the end of the day, what it's going to do is this. It will go with the product entity, will go to the product execution to make this function no longer a suspendable function. And inside of it, it will try to do the beginning of the transaction, the insertion. The transaction will be successful, it will return a unit, and pretty much it looks the same as the code that we were seeing, right? Except that this is running on a coroutine room execution with a callable inside of it. And this callable is gonna have the power to check if the database is being executed properly. It will check if the database is open. It will check a lot of things. Because what is going to happen in this part is that this execute is the tab execute that we are seeing in there. So this execute will check if the database is open and if the database is in a transaction. If the database is in a transaction, we will just let it happen. We will go and do it. We will do the things that we need to do on it. And if it's not, we will try to check for a transaction element that we are going to review right now on a couple of slides, because we are going to be talking about the process that is happening when you might have a deadlock. So this part in here will have some specific keys. A single thread dispatcher that will perform all the executions, a context element to identify that the DAO operation are in a transaction, and a thread context element that pretty much marks the threads that are dispatched during the transaction offline. Okay, so this is gonna be cool, I promise, because right now you can have in Room, you can have normal suspendable coroutines, and these are pretty much suspendable functions. And I don't want to repeat the word suspendable, but it's asynchronous. You get it, it's a one-shot, you launch it, and everything is going to be fine. And you might have some things on flow, right? Pretty much streams data, especially because we might need to have some streams of the data that we are pushing to the database, right? They are called, and this part in here is so important, because when we are trying to deliver the data, and we are trying to do the schema that I was showing, that it push data again after some update of the data, some updates of any API, and you try to push it. You might want to try to put this emit and get it on the view models, and then populate the data and make it simple for the user, so he doesn't have to do maybe a pull to refresh just to get new information. So the only thing that is going to be changing in this part, you might have this normal suspended function, right? It's a query, it looks good. You might have this suspended function, and this is getting to our table that goes all our products, because we are a retailer right now. And when we get all our products, we might have the return a product entity that is going to be the products, maybe vegetables, carrots, maybe some fruits. And the part of the float is actually that the suspend function is going to return a float. You just have to put it. You have to say that it's going to return a float. And the DAO will make all the work and make some of the changes on the code generated by Room. And in the part of the view model, this is gonna look something like this. It's gonna be, you are gonna have your view model launch, your view model scope, because it has to run inside a coroutine, and you might have your product DAO and go and collect all your data. This looks nice. This looks simple. This looks exactly what we should be doing if we want to try to do it. Especially because let's remember that when you are running some things on the on coroutines, you might have dispatcher and IO and dispatcher main, right? And the dispatcher IO is a shard pool of the threads that are to offloading the blocking operation, right? And dispatcher main is pretty much when you are or users are trying to interact with our app, right? So the things that are happening inside Flow are really different of everything that we usually see on coroutines, because this is something that is going to happen. If you are using Flow, you are going to end up with something like this. You're going to have your builder, and your builder is going to have a flow collector that is the function that you want to execute on a flow. And you are going to have your safe load, right? And the part of the safe load is that, well, the first part of the flow is that creates a cold flow from a suspended block, right? The emissions from the flow builder are cancelable by default. Each call of the emit also calls, it makes sure that the call is still active. So the emit should happen strictly in the dispatcher of the block that is running. So if we are not doing that, this is not going to work. And the part of the safe flow, the part that is going inside the safe flow, the safe flow is used. This part is used as an intermediate for making sure that we can make some terminals collections of the flow and return the correct things that we want to address, right? And the part of the abstract flow is very much what you might find in the part of Kotlin, is a flow that will be consumed in this. Sorry, it will be consumed on this part. It's pretty much the result that is going to be returned from this code. And you will get the coroutine it will try to collect and try to release the intercept, and everything is going to be okay. This is pretty much what is going to happen with your room abstractions. So once you go to your DAOs and try to access to that data, it's going to over all this. It's going to go to all over these interfaces, try to deliver the data inside a meet, inside a dispatcher, and try to deliver it without any problems. Once you have your abstract flow, once you have your flow, you are ready to go. You can use it. It's straight out of the table. The thing about thread is that unreconciled transactions are thread confined. And when I say they are thread confined, is that there might be the possibility that if you pause, you make some pause on your coroutine and you are trying to execute some DAO, some queries, some inserts, some deletions, and you get an insight outsider transaction, you might end up not running this on the same thread. And this is also known as a deadlock, right? So bear with me, I made some animations because you might have this click from your user that is will throw maybe some response from an API, maybe something else, and you might want to do an update on your tables, right? And this is all. Everything here is happening on a suspension thread, right? It's running on a coroutine. Maybe it's a float, maybe it's not a float, but everything here is going to be happening in that part, right? And it's going to be really simple, because if we get an outsider force and an outsider API that it gets and has to do an insert, but inside the first part, we want to do a delation too, these are gonna be thread confined. So the first part are gonna try to be executed on some other thread. Once the insertion notice that no one is using that thread, is gonna try to use that thread, right? And here is the problem, right? Because the deletion is gonna happen in other thread, because right now the first thread is used by the insertion, right? And this is a deadlock. You might have some troubles if you are doing it like that, especially because we might have some troubles if we do it like this. Let's imagine we are a retailer and we have all the products, and we have we want to go for all the products. We are gonna get it from the database, and because we don't know how to build APIs, we are getting the products image from another endpoint, right? And these two operations on the database should happen at the same time, but at least not at the same time, but they need to be sequentially, because if we don't do it, we cannot populate the view. We get all in the view, we got all the products, and it has all the image. So this gonna get inside the dispatcher IO, and this is going to be on a thread, right? But let's imagine that somehow we get, maybe we have a worker, maybe we have some things in Apollo, maybe we have some other API, or even we are just launching the two calls and they are unaware of each other. If these three calls are unaware of each other, what is going to happen is that maybe get all products will not be executed. And if we ended up with this, with this specific case of implementation. If we cannot get all the products, this is going to be really difficult to find. Like it's not going to happen all the time. It's going to happen only a couple of times when we are trying to deliver this information to the user. Maybe we are not even gonna know it's gonna happen. Maybe it will go for years and we will not even notice, right? This happened to us when we were doing these guides for tourists because we were trying to populate the database, and inside all the transactions that we were having to get all the cities, all the points of interest that the user might use, and all of these things, exactly at the same moment we were trying to populate the favorites of the user, we were trying to get some collections that were promoted by by a third party, right? So in this specific moment, we were crashing everything. So many users start complaining why we are not getting all our favorites. And found this error. It take us a long time. So I'm really happy that now Room has support to try to figure it out how to perform this part. And this is with something called with transactions. It's like the coding from with context. You can run this inside a coroutine, and maybe I'm putting a global scope, but you can put whatever you want. Choose a dispatcher for the execution of the transaction, and you are gonna end up with well, what is going to happen is that Room will only perform at most one transaction at the time. So if you need to finish this specific transaction inside your code, and you have another operation that needs to be executed, it will wait. Pretty much what is going to happen is that Room is going to take some ownership inside the dispatcher that you are executing. So be careful with this, because if you are using dispatcher main, it's going to be a mess. But it will take the dispatcher. It will take some ownership inside of it, and it will try to do the transaction without having some interference from other outsiders. So both of the both of the integrations are going to be happening smoothly. You will not have some transaction that might not be executed, and it will check, this part will check that if the database is open, if the database is inside a transaction, because everything is going to be in a quick, and everything is going to happen as soon as be requested. So this is great. This is amazing, because if you were not doing this, you will have some issues on your code, and it was very much awful. Trying to solve that part. So that's the part of the trading. I think it's really important that we notice that we might have some problems if we are not doing our coroutines, especially in or insertions or updates or deletions, without having these constraints of behavior inside a coroutine. Because if we let them free, it's going to be really painful and really difficult to try to figure it out what we want to build and what we need to be solved. So give it a try. Room is amazing. I'm not saying to move. If you are in SQLite Delight, stay there because it's amazing. It's an incredible database. If you are in Realm, you can also stay in Realm. It doesn't matter. I got the question of the encryption of Room really often. Remember, this is a wrapper. I don't want to say the word wrapper, but it is of SQLite. So you already know how to do some encryption in there. If you already know you have this motor and you can put it in your Room SQLite builder, and once you put the SQLite builder, you will execute this encryption. In the Room table, all the Room tables are going to be encrypted. Remember, just to keep the key store and the keychain keys outside your application should be happen on the key store. Don't use cipher just because it is easy. Be careful in there, because you can leak your key and you don't want that. For that, you have this specific part of your phone that only execute that part of the encryption and is secure architecture. So please keep that in mind when you are doing it, because it's really dangerous to keep it, just leave it like that, being free. Sorry. The part of DataStore and shared preference is one of my favorite parts, because people start saying DataStore versus shared preference, and I don't think this is a versus situation. Actually, I think they solve different scenarios. So they are not designed to fight with each other. I don't know if it is going to be deprecated in a couple of years. We don't know. We don't even know if like data is going to be deprecated, right, guys? So this is not a solution that is going to be fighting with each other. And the reason is that shared preference are pretty much synchronous, right? They are synchronous because they only have primitive values. I know a lot of people are trying to store a full JSON, a full JSON, a full database, and make some changes and use shared preference and maybe being a little abusive with it. They are designed to solve minor things, guys. So let's keep it simple. Let's store some things. And I know I have a good feeling. It's a gut feeling that shared preference is not going to be deprecated anytime soon, because they can be encrypted. And this is my favorite thing about shared preference. They can be encrypted. They are working on a library. I'm going to talk a little bit about that. And shared preference should be designed to only keep these values that are in and out. Maybe the user saw the tutorial. I don't need it. I don't need a database to do that. I need something really small that is going to tell me that this is a shared preference. I will never put a value of this on a really simple value on a database. I feel like it's like using a bazooka to kill a spider. So I will probably use a shared preference to do it. And the new cool kid in town is DataStore. DataStore pretty much is it's the big sister of sharp preference because they are asynchronous. You can use a coroutine to start populating the data on a data store and to collect the data from the data store. Has multiple types of values, and this part is really interesting because actually you can store an object, a full object. Think about a product entity. You can store product entity inside a data store, except maybe this is an overkill if you are trying to make a substitution of your database using DataStore. They are not encrypted, not yet at least. Maybe they are working on it, I don't know. I hope they are doing it because it will be really, really cool if they are working on that. But if you ask me, I will put this in some spatial levels, like sharp preference for small things. They are tiny. They are pretty. They don't get so many space. Then DataStore because it's a little more bulky situation when you are getting so many things like tutorials or maybe promos or I don't know, something like that. And the database is the part that you want to keep it safe. You want to encrypt it. You might have some details going on in here. Probably has too many queries. If you are using Realm, you maybe have so many transactions. So I will put that like a leverage graphic. So the part of the sharp preference is it can be encrypted. So I got that feeling. It's super easy because you can start using this library. It's still an alpha. There is a release candidate with a 0. It's 1.0.0, and there's a release candidate. You can start using it. Really simple. Because the thing that is going to happen in here is that you are gonna try to create this master key. This master key will go to a specific context. Don't do this part of the application, .application context, but you will go and create this nice schema that has an algorithm of encryptation, right? Here we are using IES with a block mode and maybe some padding, and you can decide how that thing is going to create. After that, you can use that master key is going to be stored in your key store, and it's going to be encrypted. So that's really, really good because it uses the schema of master set. So after that, after using that, you will go with a master key. This master key will give you a way to create an encrypted sharp preference. It's going to look amazing. You can encrypt the keys and the values, and that's it. That's it. Everybody knows how to use a sharp preference. It's pretty much the same, but it's still synchronous. Even this part, even when you are, I know that the synchrotization, it takes a while because it's not happening on your phone. It's not happening on the moment of your application. It's actually happening in another part of the architecture of your phone, a specific hardware place, like a physical place in your phone. So I know it takes a little while, but it's actually really fast. So give it a try. But all the operations that you are going to create in here are going to be synchronous. The part of the DataStore, you can use Flow. It's super easy because it's synchronous. You're going to start using it because it's in alpha. Give it a try. It's not going to change a lot. It's actually really, really stable. It's very solid. Because what you are going to have is that you are going to end up with two types of DataStore. The first one is preference DataStore, that is your normal sharp preference. Like you can have a list, you can have a boolean, a unit, etc., an object, etc. It pretty much stores the same that what it does in a sharp preference, a key value pairs, but doesn't provide any type safety. For that, you need to use Proto DataStore because Proto DataStore is going to give you custom objects, and it provides type safety for these custom objects. But it just Protobuf. You need to give it a try. You will end up trying to create these objects that are going to be stored, and you know how it goes with Protobuf. But it's pretty much simple because you can create or migrate your sharp preference. Like right now, it takes like this amount of lines of code. The first one, if you don't have any shop preference but you want to start doing it, you can create a DataStore just doing that. Or the other cool thing is that you can migrate it from your shop preference, and the part of your shop preference is that you are going to create the DataStore and create a migration list of all the shop preference that you have in your phone. Straight up simple. I think this library is really nice. We actually migrate from shop preference because it was we have so many tutorials and many things like that, and we keep it on there. And the part that extracting data or saving data is pretty much what you will imagine. You might have a suspend function that will save something. You go to your DataStore, your preference, and your key. And the part of the flow is that you are going to try to access this. You can use a mapper. Maybe you want to use a collect, or maybe a fields, whatever you want. It will go like this, and you will get the data of the flow using DataStore. The three options that you are going to be using on your app are okay, but it depends of the solution you want to build, right? Maybe is something really, really big. You might want to go with a database. Maybe that is not that big. Maybe something around DataStore. I think we were missing this important part in here on Android development, like day to day, trying to review that. It's really cool. You will find that this is really a lifesaver. Give it a try. That's all from this talk. I hope you have enjoyed it. I think I can stop sharing my screen. I will put the slides on my speaker desk at the end of this talk, and you will find it in there. Oh wow.
Thank you so much, Dinorah, for the informative talk. Please take a little break and hydrate.
It's really cold in Mexico. It's really cold. It's not as cold as Jeff in Canada, but it's cold. So
you are where in Mexico? Are you in Mexico City?
In Mexico City. In Mexico City.
Wow, that's cool. Hope everything is safe over there. And
doing well.
Yeah.
Everything is. Oh well. You know how it is in Latam.
It's everywhere. Everywhere a problem, unfortunately. But yeah, please take a break. We have already questions in the Q&A. So when you have a chance, please take a look. And everyone, now is the time to add your questions if you haven't done so under the Q&A tab in the chat. And then when Dinorah has a chance, she can start answering. If you don't have a question, just feel free to vote for one that you like.
Okay, transactions can be used on Realm. Also, I think Secular Light has some transactions. And obviously, Room has transactions. It has a specific element that is a robot, is add transaction, right? So you can start using that. There's so many options. Like, it's not like usually when you are trying to do some things like maybe network connection, you get these specific blocks of things you can use, like tools. You go with retrofit, maybe coroutines, or you go with retrofit and maybe Java. Maybe you go with HTTP and coroutines. But in Android storage, there's so many options. So give it a try. I think almost all the Android storage DB must support transactions because these deadlocks can happen. It's possible to define a composed primary key in Realm. I'm not sure. I think on iOS it's possible. I don't know if it's on Android. I don't know if someone wants to answer that. Why coroutines can be used with anything, because you can put it specifically for Room. You can put it on an insert and a deletion and an update. You can put it another transaction, create your own transaction. Even you can create your own custom insert. So you can make your own custom insert that extends room iterable. So you can use it with anything. At the end of the day, you can use it with your network calls, maybe to populate a view, whatever you want. Everything that's going to happen in a secondary thread, you can use it with a coroutine. What do you think is a good design idea to make the product attribute categories into a preference? Because we still update the product without that attribute. I don't understand that question. What do you think it's a good design idea to make the product attribute categories into a preference? Like a sharp preference or a preference? I want to talk with the DL Stevens. If you have some time after the talk, we can talk about it. Yes. Sorry, I didn't saw the last question. Coroutines can be used in anything. Do you mean that can be used in all into databases? SecuLite has support from coroutines, and Realm has his own callbacks, so you have to do some wrappers on it. But at the end of the day, yes, you can do it. So I think that's all the questions. I'm really happy to be here. Thank you so much for having me. It was amazing.
Thank you, Dinorah. That was a great talk. We really enjoyed that. And the questions were very good too. Thank you so much for presenting. It was very informative. I hope everybody enjoyed it as much as I did. Thank you.
No, thanks to you guys. Thanks to you. I'm going to be around. Also, I'm going to be on the Slack. Big applause to everybody that is creating Android worldwide. It's amazing. You actually are the real MVPs.